Hello everyone, welcome to today's session. In our previous session, we have started gravitation chapter from class 9 and we have discussed the introduction of gravitation, centripetal force, then universal law of gravitation. We have solved two numericals from NCERT. Today we are going to learn free fall and acceleration due to gravity. Now imagine you have taken two objects. Suppose one is a ball and the other one is a notebook or a piece of paper. So when you release both of these objects, you will see that both of these will go straight down to the floor. And you might notice that ball goes faster comparison to the notebook or the piece of paper. Now why is that? Why it's happening? So you might say that ma'am, maybe the mass of the ball is larger than the notebook. But no, here that's not the case. So we know that there is air resistance in our atmosphere. So since the notebook paper has larger area, so it can feel more air resistance on it comparison to the ball. So because of air resistance, the piece of paper, it goes slower to the floor. Okay. Now what if we have created a situation where there is no air? That means it's a vacuum. So if we do the same activity, you will see that the ball and the piece of paper or the notebook, they will fall at the same rate of time. Okay, that means irrespective of their mass, both of these will fall at the same time. And this is basically the free fall. That means when the object is going down due to the gravity only, there is no other kind of forces acting on this object. So due to this gravity, we can call it free fall of that object. And due to this gravity, that object is going down. That means that the object is accelerating. So this acceleration is basically called as the acceleration due to gravity. Now, since acceleration is due to the gravity only, so we call this as small g. Okay. Generally, the value of g is 9.8 meter per second square, and this is the formula of g that we're gonna establish later. Okay, now we know that gravitational, from the first lesson we got to know that gravitational force F is equal to capital G, which is the universal gravitational constant. Capital M is mass of one object, small m is mass of other object, and divided by r square. This is basically the radius of the earth. Now here gravity works, and because of gravity we can see there is motion in that object. So from Newton's second law we know that F is equal to mass into acceleration, right? Now we are gonna equate these two equations. So we're gonna write ma is equal to gmm divided by r square. Now see here, small m and small m will gonna cancel out with each other. So this is A is equal to capital G m by r square. Now since we are talking about gravitational acceleration due to gravity, so G is equal to capital G m upon r square. So from this equation we got to know that acceleration due to gravity only depends on the mass of the earth, because capital M is basically mass of earth and capital G is gravitational constant and r is radius of the earth. That means whether the object is a smaller object or a larger object, a mass of one object is larger than the other one, it doesn't depend on the mass of that object. The acceleration due to gravity only depends on the mass of the earth and radius of the earth. So whether it's a feather, whether it's a hammer, it doesn't matter. The acceleration due to gravity, the value would be 9.8 meter per second square for every object. Okay. Now we're going to see the equations of motion under gravity. Now basically when objects move under gravity's influence, we use the same equations of motion that we have learned before. Okay, so basically we know there are three equations of motion. The first equation is that v is equal to u plus at, where v is the final velocity, u is the initial one, and a is the acceleration, and t is time. So here, since we are talking about acceleration due to gravity, so we just replace that a by g. So then we are going to get the equation as v is equal to u plus gt. So this is our equation motion under gravity. The second equation of motion is, we know that S is equal to ut plus half at square. So same here also, you have to just replace that a by g. So we're gonna get ut plus half gt square. And the third equation is that v square minus u square is equal to 2as. This is our third equation of motion. So here also we are gonna use g here. So v square minus u square is equal to 2gs. Now one thing you have to remember, that here we need that sign convention. Why it's important? See, because when free fall happens, so objects go down. So that means the acceleration due to gravity is positive. Okay, because we know acceleration is a vector quantity. But what if we throw any objects in the upward direction? So that time we have to consider that acceleration due to gravity as negative. So if any question comes, any numericals question, so if any object is going in the upward direction, so in every equation you have to put minus of g in that equation. Okay, so this sign convention is very much important to learn while you're doing any kind of numericals from this equation of motion under gravity. Okay, so we're going to solve one question from this part. Now we are going to solve the numerical from NCERT, and it says a ball is thrown vertically upwards with a velocity of 49 meters per second. Calculate, the first one is maximum height to which it rises, and the second one is the total time it takes to return to the surface of the earth. Okay, so here the ball is going in the upward direction. Okay, let's say the maximum height it reaches, that is capital H. And here, since the ball is going in the upward direction, that means the acceleration due to gravity would be minus of g. Okay, so the given data are, the initial velocity is given, that is 49 meter per second. So when it reaches to the maximum height, the final velocity is 0. So 0 meter per second. Now we are going to use the third equation of motion to calculate the first question. So we know that v square minus u square is equal to 2as. So we are going to replace that a as by g, and the maximum height is h. Okay, now just substitute the value. So v is 0 minus 49 square, which is equal to 2 into, now the value of g would be negative, so minus of 9.8 meter per second square, because we know g is 9.8 meter per second square, but since here the ball is thrown vertically upward, so we have to take the negative value of g, then h. So after calculating this, you will be getting h is equal to 122.5 meters. So that is our maximum height in which that ball will rise. Okay, so to calculate the second one, it is said the total time it takes to return to the surface of the earth. That means here the ball goes in the upward direction first, then it comes back. Okay, so let's imagine the time taken when the ball is going in the upward direction, that is t1, and that means time to ascend, and time to descend is t2. Okay, that means total time would be t1 plus t2, and both of these times are, the value of the time will be same. Okay, so we are gonna do one thing. We are gonna use the first equation of motion, which is v is equal to u plus gt. Okay, now v is 0, u is 49, and g is minus of 9.8. so here, let's say this is t1, because we are using the data to calculate the time to descent only. So let's say t1. So this would be, t1 is equal to 49 divided by 9.8. So this is 5 seconds. So time to ascend and time to descend would be the same time. So this is t2 would be 5 seconds as well. But the total time is t1 plus t2. That means 5 plus 5 seconds, which is 10 seconds. So that means this is our answer. So the total time it takes to return to the surface of the earth would be 10 seconds. Okay, so I think you understood. Thank you for watching.